In this problem, two stern garlic apparatus S1 and S2 are kept in a line. The direction of their magnetic field are along positive Z and Y axis. Each apparatus transmit particle with spin aligned in the direction of magnetic field. If an initially unpolarized beam of spin half particle passes through this configuration, the ratio of intensities I initial with respect to I final would be. So let us make it in a proper way. That is S1. Now direction of this would be positive Z axis along positive Z. This is S2. Its direction is plus Y cap. So initially unpolarized beam of particle is coming. Now stern garlic can give us either plus H cross by 2 or minus H cross by 2 spin. So since question is saying only positive direction is emerging out, so that means there would be no transmission along this line. So we would be getting this H cross by 2. Now this H cross by 2 is again passed on apparatus Y. S2 having direction along Y. So again in general this would have given a minus H cross by 2 and this would have given positive H cross by 2. The question is saying only a spin along positive direction would emerge from the apparatus. So here there would be no transmission of the particle having a spin down. So this spin was further reduced to H cross by 2. That means initially if that is 0, so I0 intensity, here it would be I0 by 2 and here it would be I0 by 4. ठीक है? So the ratio would be, so initial intensity would be, initial intensity is of beam is I of I initial is I naught final in of beam is I final is I naught by 4. Thus the ratio of I naught by I5. Thus the ratio of I initial by I final to I naught by 4, that is 4:1. So our option would be C, which is correct for this question. A Hamiltonian of a spin half particle in magnetic field is given by H equals to minus mu B dot sigma, where mu is real constant. Sigma is defined in terms of Pauli's matrix sigma Z. And now if B is along 0, B0, 0, T, and the spin state at T0 is an eigenstate of sigma x, then B is B0, 0. That means H can take minus mu B0 sigma x plus sigma y. According to question, at t is equals to 0, spin state is an eigenstate of sigma x. So eigenstate of sigma x is 1 by root 2, 1 plus minus 1, which can be written as 1 by root 2 of spin up state plus minus spin down state. So that is wave function psi x at initially 0 state. Now the time evolution of wave function after time t is psi t is e to the power minus I h t by h cut into psi x 0. So which can be written as e to the power minus mu b h cut sigma x sigma y t into psi x 0, which can be written as omega I omega xt into I omega sigma y t to psi x 0, and we can expand it this term like cos omega t plus I sigma x sin omega t into cos omega t plus I sigma y into sin omega t into sigma x 0, that is psi of t. Since psi of t depends on time, that means expectation value of sigma x, sigma y and sigma z also depends on time, which means they changes with time. Hence, our option D is correct. That is expectation value of sigma x, sigma y, sigma z all changes with time. A particle of mass m is constrained to move in a circular ring of radius r. When a perturbation of v is added, the shift of the ground state to the first order in E. So for a particle constrained to move in a circular ring of radius r, its wave function and corresponding energy eigenvalues are given by E L equals to ml square hk square by 2ma square, and psi of phi is equals to 1 by root 2 pi e की power I ml phi. Vp is defined as a by r square cos square phi. So first order correction in the ground state, energy of the particle is E01, E11, psi1 will be psi1 phi, V psi1 phi will be 1 by 2 pi 0 to 2 pi a by r square cos square phi d phi is equals to a by 2 pi r square 0 to 2 pi 1 plus cos 2 phi by 2 d phi, which is equals to a by 2 pi r square 2 pi by 2 plus sine 2 pi minus sine 0 by 2 is equals to a by 2 r square. So the energy shift in the energy of ground state is given by a by 2r square. That means option C is correct for this problem. A particle of mass m is confined in a three-dimensional box of potential V, x, y, z. This the number of eigenstate of Hamiltonian with energy is. So we have to determine the energy corresponding to degeneracy of eigenstate corresponding to this energy. For potential x, y, z equals to 0 to infinity, 0 x, y, z equals to a, otherwise the energy of the particle is given by E and x and y z is equals to nx square plus ny square plus n z square pi square h square by twice ma square. According to question, E and x and y and z is equals to 9 by 2 pi square h square by square, equating to energies. We get thus degeneracy in the eigenstate corresponding the given energy is 3. Thus, our answer is option C for this question. The energy of a free relativistic particle E is defined as, we can write it down, P square C square plus M square C की power 4, where M is mass, C is speed of light, and P is momentum. Now the question is asking the ratio of Vg, Vp of a group of the group velocity Vg of quantum mechanical wave packet to the phase velocity Vp. So we have to determine the ratio Vg by Vp. Now Vph is defined as omega by k. We can write it h cross omega by h cross k, which can be written as E by P. Vg is defined as d omega by dk. We can write dh cross omega by dh cross k equals to de by dp. So further, from relation p square c square plus m naught square c की power 4 twice e del e by del p is equals to 2p c square. 2 से 2 cancel, so del e by del p will be pc square by e. Vg will be del e by del p equals to pc square by e, which can be written as c square by e by p, or which can be written as c square by vph. So when we would be taking the ratio Vgh by Vph equals to c square into Vph into 1 by Vph equals to c square Vph square equals to c square a square by p square, that means c square p square by e square. So our correct answer would be here. This option should have C. So this is typing error. Option C is given p square c square by e square. This problem is related to WKB approximation, and here the nth energy eigenvalue En of an one-dimensional harmonic Hamiltonian H p square by 2m lambda x की power 4 in WKB approximation is proportional to. So we would be writing one result, general result for general potential Vx defined as Vx is equals to lambda mod x की power m. In such cases, Hamiltonian become p square by twice m plus lambda mod x की power m. The energy corresponding to this potential is E m proportional to lambda 2 m plus 2 into n plus half 2 m into m plus 2. Now comparing the value of and with the question we get m is equals to 4. So E4 is proportional to lambda 2 plus 4 to n plus half. 2 into 4 divided by 2 plus 4 is proportional to lambda 2 by 6 to n plus half 8 by 6. So E4 is proportional to lambda 1 by 3 n plus half 4 by 3. So let us check which option is correct. Option 1, lambda 1 by 3 n plus half 4 by 3. This problem is related to quantum scattering, in which we have to determine the differential cross-section area sigma theta for potential VR equals to beta r e to the power minus mu r. Now, we would be solving this problem by assumption. Let us assume mu is equals to 0. In that case, my VR reduced to beta by r, that is Coulombic potential, and in Rutherford scattering, for such potential, sigma theta is proportional to cosec की power 4 theta by 2 or 1 by sin की power 4 theta by 2. So let us check from option to get. In which sigma theta is proportional to 1 by sin की power 1 by sin की power 4 theta by 2. So we can directly eliminate option A and D. Yes, sigma theta is proportional to sin square theta by 2 or sin square theta by 4. In option B, it is proportional to 1 by sin square theta by 2. So in option C, A square plus sin square theta by 2 minus 2. We can neglect this, so we can say it is proportional to 1 by sin की power 4 theta by 2. That means option C is correct for this problem. In this problem, the wave function of a free particle confined between two infinite wall, or you can say in one-dimensional potential well, is given by psi t equals to 0 x root 2 by L sin pi x by L minus sin 3 pi x by L. So we can write it this like root 2 by L sin pi x by L minus root 2 by L sin 3 pi x by L, or simply phi 1 x minus phi 3x. So wave function at time t is given by psi of 2t and x phi 1x e to the power minus I e1 t by h cross minus 3x e to the power minus I e3 t by h cross. So phi 1x e to the power minus I pi square h square by 2 ml square t by h cut minus phi 3x power minus I 9 pi square h square 2 ml square t by h cut. Further, question has defined t is equals to ml square by 4 pi h. The t is equals to ml square by 4 pi h cut. Now psi t equals to t and x will be phi 1x e to the power minus I pi square h by 2 ml square into 4 pi h cut minus phi 3x e to the power minus I 9 pi square h cut divided by twice ml square into ml square by 4 pi h cut to h cut cancel. So we would be having it 5x e to the power minus I pi by 8 minus phi 3x e to the power minus 9 pi by 8.